Hello everyone, this is Zoya Farajpur from the University of Memphis Civil Engineering Department. I'm going to speak about my research application of support vector machine for classification of induced and tectonic earthquakes in the central and eastern United States. As you know, induced and natural tectonic events potentially are similar, and a large number of seismic events in the suspected areas make challenges for identifying man-made seismic events. What is the induced seismicity? Induced seismicity refers to seismic events, usually earthquake, caused partially or completely by human activities. Several methods that leads to earthquake induced by human activities like geothermal activities, water injection into the earth, mining activities or exploration, oil and gas operations such as hydraulic failure and dumping of the dam. Currently, the seismicity rate in the central and eastern United States is very high, and the scientists believe this dramatic increase in the number of small to moderate earthquakes started since the end of the 2008 until now. Increased seismicity rates followed by appearance the number of wastewater disposal wells was notable, especially in Texas, Arkansas, and Oklahoma. The notable impact of induced earthquake on people's life motivates scientists to concentrate on the evaluation of induced earthquake in the central and for this study, we use a subset of NGA East and Gupta et al. 2017 databases. The selected ground motion records from thousands of events recorded at the station spread over the central and eastern United States region. On the right side map, you are seeing the location of earthquake event and stations which are available for this study and on the target area, and on the left side map, which is from Peterson et al. 2015, the colored polygons showing where the potential induced earthquake location is. For this study, we use the database which includes the tectonic natural earthquakes, which we take them from NGA East catalog, and also induced earthquake. Also, they are the induced earthquake which flagged in the NGA East catalog as well, and a comprehensive test dataset which contains the earthquake events. And these events, about these events, we don't know they are induced or tectonic. Just we have the moment magnitude range between 3 to 5.8 and depths up to 15 kilometers and distance up to 200 kilometers. For this study, we use support vector machine as one of the most efficient machine learning algorithms to classify induced and tectonic events. The SVM is selected due to its efficiency, stability, and high accuracy compared to several widely used machine learning-based classification techniques. The SVM is a supervised learning model that is developed by Wapnick 1995 based on statistical learning theory. The SVM classifies objects by constructing a model or classification function that assigns new observations to one of the two classes on either side. To construct the SVM model efficiency, Cross-validation is used as the parameter selection technique to find the optimum turning parameters, including the penalty parameters and the spread of the RBF kernel. The performance of the SVM is evaluated by a confusion matrix as shown below. The accuracy shows how often classifier is correct by dividing the summation of true positive and true negative by the total number, which here equal 80%. This good accuracy shows that the SVM model of this study works well. We also estimate sensitivity and specificity as two statistical measures of the performance of a binary classification. In this study, sensitivity refers to the ability of classifier to correctly identify the tectonic events, and the specificity refers to the ability of the classifier to correctly identify the induced earthquakes. The results show that the sensitivity and specificity values are 79% and 80% respectively, indicating a good performance of the SVM classifier of this study. In this study, we considered three large comprehensive data sets for applying the methods to classification induced earthquakes from natural tectonic events. For this purpose, we use SVM as one of the most efficient machine learning algorithms. In this study, the data sets that we use includes the NGA East tectonic natural and induced earthquakes, and a comprehensive test dataset that contain the earthquake events with magnitude range between 3 to 5.8 and depths up to 15 kilometers and distance up to 200 kilometers. The accuracy of the classification approach is obtained with a k-fold cross-validation procedure. The result of this study demonstrates the feasibility and effectiveness of the SVM to classify the induced earthquake from natural earthquakes in the central and eastern. This research is still going on at the present time. Please follow the research result on ResearchGate, and thank you so much for your attention.